Let's go through Liquid 123, best time to buy and sell stock 3. For this question, it gives us prices, integer array, and you can make at most 2 transactions. It asks us the maximum profit. So you must sell the stock before you buy it again. So we have another question we just did a moment ago that we can make k transactions, right? So for this question, we can consider it a special case for the k transaction buy and sell stock. It is just an buy and sell stock just twice. So we still use dynamic programming to solve this question. The things that we need to have have 2 arrays, right? So now in this case, we also need to have 2 arrays. One is we will call them hold. Int equals new prices of length. So equals new int n minus 1, n plus 1, and 2. And I will have so equals new int n plus 1 and 2, right? So we'll say for the hold we set the initial value, right? So so we'll have hold 0 0 equals the integer dot min value, and hold hold 0 1, right, equals integer dot min value. So the same thing about the physical definition, right? Hold I 0, right? What does this one mean? Is that for the it defines for the previous ID, right? That is the index I minus 1. We don't buy we buy 1 at most once. Okay, 0 is actually for the question a moment ago we use 3, right? We add a 1 actual here, but the thing is that actually possibly we use 2 will be enough. Two will be a moment ago we use k plus 1 times k plus 1. So what we can also is 3, right? And we'll have hold 0 2 equals the integer dot min value. So J, right? So J we transaction at most j times 0, 1, 2, right? We transaction at most j times max. We hold, I say not transaction, right? We buy at most j times max profit. And we can buy at this day or not, or in a previous day, right? Yeah. So so the same thing is that we do the k times, right? So that is for int I equals 1, I smaller equal to n, I plus plus. Right? So we know a moment ago the transaction function is that vp I j equals sorry, sold I j equals max dot max sold I minus 1 j, or we hold, right? Hold I minus 1. J and so the price minus 1. So this is a hold transaction function, and we'll have the hold, right? Hold is J equals max dot max. That is we hold in the I minus 1 previous I minus 1 day, right? And we sold I minus 1, but the things that we need to minus 1, right? And minus prices I minus 1. So this is the for the k times, right? But for the 2 times, right? For the we 2 times we don't need to use a G loop. We can just write the function, right? So let's say the sold I there would be max dot max sold I minus 1 there, and hold I minus 1. We are not there, we are having an actual, so that is 1 and 2, right? So 1 hold is 1 plus price minus 1. Okay. And we have a hold I 1 equals max Up next, hold I minus 1. One, okay, and we solve I minus 1. This will be 0, right? And the minus x is I minus 1. Okay, and also we have 2, right? For the 2 scenario. That is we solve at most 2 times. 2 times. This will be 2. This will be 1, right? In the end, we get the return. So and good, right? So this is similar to what we do for k times. Yeah. So we'll say this is initially as 0, right? So we don't need this variable, right? And hold 0, 0, it's not being calculated as well. This one hold 0, 0. It's never being used. We don't need this. So this will be our question to answer this. If I write this, it's kind of straightforward, right? But we can get the formula a bit simpler, right? Because you see, we are actually using because we can change this one to be rolling array, right? That means we can use some kind of variables to represent the values. A better way is that we need to have we can use something called B1, B2, and H1, H2, right? Those 4 variables. That will be enough. We don't need this array, right? So we'll have so we are going to use 4 variables for this question. That is the hold 1, right? Hold 1 at the beginning to be integer dot mean value, and so 1, right? So 1 equals to 0, and hold 2 equals integer dot mean value, and we'll have so 2 to be 0, right? So we just change this kind of variable. Just say we'll have at the beginning we'll use the previous round to save into in the previous h1 equals h1. Previous s1 equals s1, and the previous s2 equals s2, and previous h2 equals h2, right? So we'll say this s1 equals previous s1, right? Previous s1, previous h1, previous h1, and we'll say h1 equals previous. This is previous h1, and s2 will be previous S2, and this is the previous H2, and I will say H2 was previous H2, previous S1, right? Previous S1. And what we return is S2, right? So we can write a function like this. This looks much clean. Yeah. Yeah, so this will be the solution for this question. And actually, this one we'll see is just the same as the base stock buy and sell one, right? We don't need if you are not familiar want to do like this way, you can just write them because the whole maximum is just trying to get the minimal prices we are trying to buy, and this is just sell once, almost once. So this one is just if we return S1, it's just the buy and sell stock one. So this part you can also use the way get a previous mean to replace. So you can in that case you don't need the H1 variable. Doing like this, the time complexity will be O(n). Space is constant. I want to mention that if we open DP array like n, that will be O(n) space, right? If we're using rolling hash, that will also be constant. So doing like this way will be better than there is another way to do this question. Another way is called a divider. I like another way is that we need to calculate for we use some index to move from the left to right. Calculate for this range the maximal profit, and this range the maximum profit. But doing like this way we can use just constant to store, right? To store the previous minimum. But for this one, we need to do some preparations to write to do preparations to compose a right max array. So in this case, the space complexity will be always O(n) doing like this way. Even doing like a divider board, trying to move from the left to right, the time complexity is also O(n), but we cannot save the space complexity doing another method, that method. So the most neat solution is like this, and also space complexity is better.